Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tambaram, Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series in applied electronics, and in the lecture number 21 we will be discussing the phenomenon of polarization, and the contents of this lecture are introduction to polarization, plane polarized light, optical activity, Biott's law, and polarimeter. Now, what is polarization? All of you would have heard of Polaroid camera, and not only that, you may be wondering as to why the cricket players are wearing colored glasses. You may be feeling that a catch may be properly caught or it can be dropped. Why, in spite of the fact that they are wearing glasses. Why should they wear the glasses, right? Okay, they are the polarized glasses. So, polarization is an interesting phenomenon. Now, what is polarization? Schematic diagram of a light wave. Light wave is an electromagnetic wave. It propagates at a velocity c in the x direction. The velocity of light is c. It is propagating along the x direction. The electric field vibrates in the xy plane. Where is x here, y here? The electric field is vibrating in the xy plane, the electric vector. The magnetic field vibrates in the xz plane. This is the blue xz plane. This is the blue. They refer to the magnetic vectors, the electric vectors, right, which are vibrating. But see that the directions are upward, downward, upward, downward. So, an unpolarized light will be having the electric vectors vibrating in all possible directions. This is the ordinary light. Ordinary light is said to be unpolarized. The light is coming in this direction. The electric vector will be vibrating in this direction, and in all possible directions. So, you see the vibrations in all possible. This is the plane, right? The plane of vibration, the plane which contains all the vibrations. You know, the vibrations are found in all possible directions, right? So, the unpolarized light. Now, you have a material called a polarizer. The polarizer, what it does is, when the light is passing, the polarized light is found here. Their vibrations are in all possible directions. Now, after passing through the material, a glass piece which is called a polarizer, the light is said to be polarized. Polarization means what? Polarization in a political party. What do you mean polarization? It is a one-sidedness. All vibrations are, all people are, all party members are supporting for a particular cause. They are taking a particular line of thinking. It is called polarization. The views are polarized. Similarly, here all the vibrations are confined to a particular plane, right? The vibration, instead of vibrations being found in all directions, the vibrations are found only in one direction, then it is called a polarized light. The unpolarized light consists of vibrations in all directions perpendicular to the direction of travel. You know, light wave is a transverse wave. Plane polarized light consists of electric vectors vibrating only in one direction perpendicular to direction of travel. This is the direction of travel, right? In only in one direction, right? Direction is that is a particular plane. This is a plane of vibration, right? You call it plane of vibration. Plane polarized light. The objective, students should understand the transverse nature of light waves. You all know that sound waves are longitudinal and light waves are transverse waves. This phenomenon of polarization is the one that shows without any doubt, it shows clearly that light waves are transverse in character. The transverse nature of light waves is brought out by the phenomenon of polarization. So, it is a very important phenomenon. Light waves can explain qualitatively why light can exhibit polarization. So, the unpolarized beam wherein you see the vibration in all possible directions is called a polarizer. Then all the vibrations which are in different directions are cut and you see vibrations only in one plane, right, the vertical polarization, right. Okay. So, this is a polarizer, then it can be made to pass through another material. Anyway, the point is now here the vibrations in all directions, all planes, here the vibration is confined to a particular plane. This light is called polarized light wave. The incident beam is unpolarized, wherein the vibrations are in all directions. Let us look at the longitudinal wave, the sound wave, where is the velocity of propagation, the spring is made to oscillate, right. The oscillations are in this plane, right, in this direction, right. The transverse waves, light waves, direction of light waves in this direction, as I told you, the electric vectors will be in a particular plane. This is a plane, right. This is only in this plane, right. Okay. Unpolarized light wave is vibrating in more than one plane. A polarized light waves are vibrating in a particular plane, not in all planes. Polarization, the process of transforming unpolarized light into polarized light by using a polarizer. A polarizer is a quartz glass or calcite crystal or tourmaline crystal. Several crystals exhibit the phenomenon of polarization. That means cutting the vibrations which are found in different planes or different directions. There will be vibrations only in one direction when light is made to pass through a quartz crystal or a calcite crystal or a tourmaline crystal, which are called polarizers, right. So, you have the light, the unpolarized light usually is represented by two mutually perpendicular directions, because all the vibrations which you have got in different directions, the resultant can be obtained along two mutually perpendicular directions, one in this direction, one along this direction, right. So, you represent the unpolarized light by drawing two mutually perpendicular light to vibrate in two mutually perpendicular directions, the unpolarized light. A polarizer is a medium like a quartz crystal or a calcite crystal, which is capable of cutting the vibrations in a particular direction, in a particular plane. Here you get this is cut off, right. The vibration electric vectors which are vibrating along this direction in the electromagnetic wave, they are removed when light is passing through such crystals which are called polarizers, and they are polarizer which is able to produce this unpolarized light and get into what is called obtain a plane polarized light. Now, this is called plane polarized because it is a plane of vibration, right. All the light beams is confined to this particular plane. You call plane of vibration or you call plane polarized light, and you can have an analyzer. Supposing the axis is vertical, axis is horizontal, right, and no light will be there. So, you can have another crystal, they are said to be in crossed positions. Crossed polaroids can eliminate light, it can cut off the light. This one cuts the one kind of vibration, only this kind of vibration are present. This crystal placed in a particular direction can cut off these vibrations also, eliminating the complete light. That means light can be completely cut off and there will be only darkness. Often a plastic called Polaroid, a Polaroid camera discovered by a 19-year-old Harvard undergraduate student called Edwin Land in 1928. he showed that unpolarized light, which is represented by this kind of representation, it is made to become plain polarized light having a vibration only in one direction. When it is passed through a polarizer, a material, a Polaroid or a polarizer, making the unpolarized light into a plain polarized light, this leads to what is called polarization. This phenomenon of polarization can be understood by this analogy, picket fence analogy. When the pickets of both fences are aligned in the vertical direction, you have this kind of wooden panels. You got wooden panel here, a vertical vibration like this, right? You make the string to vibrate or a rope to vibrate, it is vibrating, right? You have this hand here, another hand here, you make it vibrate, it will go like this, it will go through this, right? Supposing this is kept perpendicular, what will happen? Suppose you make it rotate it through 90 degree, then what will happen to vibrations? You should imagine what will happen to vibrations. They will be cut off, right? As I show you the next diagram, they will be cut off. That is a cross position. The pickets or the second fence or horizontal, vertical vibrations which make it through the first fence will be blocked. That is what the analogy, all vibrations are removed and you have got only one vibration. That also can be removed by what is called a second analyzer, that is what I showed earlier, and no light will be coming. And similarly here, the light can be completely cut off if fence is made to become perpendicular to this opening, then the light can be completely cut off, right. Polarization can be effected by reflection, refraction or double refraction. When an elementary light wave interacts with matter, its electric field causes electrons within the substance to vibrate at the wave's frequency. These vibrating electrons then re-radiate the absorbed energy as new electromagnetic waves in all directions. Although the scattered light has the same frequency as the incident wave, its polarization depends on the new direction of propagation. In general, therefore, when light interacts with matter, its polarization can be changed. The main mechanisms by which this happens are by passing light to travel through dichroic materials, passing light to travel through birefringent materials, or by scattering, or by reflection, or making light to pass through optically active materials. I will be talking about polarimeter, some solutions like saccharimeter, you can have sugar solution, you talk of optically active medium, they rotate the plane of polarization, and so passing through optically active materials. If you have got unpolarized light, this is the representation given to unpolarized light. When light is made to be incident on a glass piece, right, you have got a glass piece, you have got air here, you have got a slab, glass slab here. When light is incident, as all of you know, you would have done the experiment in a lower level, the phenomenon of refraction, that a light trying to pass through a slab, light will undergo partial reflection and partial transmission. Now, when light is made to be incident from the medium air into glass, then partly it will be transmitted. Now, this unpolarized light will become plane polarized, the reflected ray also is polarized, the refracted ray will also be polarized. Now, the unpolarized light will be, you can put a plus sign, from the plus only this will be carried in this direction, the refracted ray is polarized, the reflected ray also is polarized. Reflection, refraction, you get plane of when the unpolarized light can be converted into plane polarized light. Again, look at this particular thing, this is a beautiful diagram. Unpolarized light, you have got air here, water here, water surface, you have got a water surface. You know water has got a refractive index of 1.33, you have got a water surface here. The light is coming in air, this is a representation, that is a dot and an arrow, that refers to unpolarized light. You have got a vibration in this direction, vibration in this direction, the dot refers to vibration in this direction. Okay. This refers to, this arrow refers to vibration, two mutually perpendicular directions. One is the dot is one direction, 90° you got the arrows, right, the unpolarized light. So, when light is incident on this surface, air water surface interface, then light will be partially reflected, and this partially reflected light will be polarized, right. So, you have got dots here, polarization in one direction. Then a part of the light will be transmitted to into water, and it goes to the glass block which has got a refractive index 1.50. With respect to water, it is a denser medium. So, when light is incident on a denser medium for a rarer medium, again this unpolarized light is again made to become plane polarized light. So, when there is a difference in refractive index, polarization will occur. So, ordinary unpolarized light or non-polarized light consists of many beams vibrating in different planes. You have got many beams different vibrating in different planes, okay, different planes are there. A plane polarized light consists of only those beams that vibrate in the same plane. So, this is a plane. So, this is what I am showing here, this is a plane. It is vibrating like this, right. Here this is vibrating like this, they are vibrating like this. So, this is unpolarized light. All vibrations are allowed. A plane polarized light is one where the vibrations are confined to a particular plane. It is called plane of vibration, which is perpendicular to the plane of polarization. Unpolarized light is represented by this, plane polarized light is represented by this diagram. So, what happens to ordinary light that you have got here, when it is made to pass through a quartz crystal or tourmaline crystal or a calcite crystal, things differ, right. The behavior of light will be differing, is getting polarized. You know, the cricket players are wearing glasses. I will explain the polarization of light. You got the unpolarized light. Let me place a nickel prism. Person by Nickel, he made what is called a material which will give rise to the phenomenon of polarization. So, the unpolarized light, when it is passed through a nickel prism, it acts like a polarizer. What is a polarizer? Unpolarized light is made to become a plane polarized light. Here you have got vibration in all directions, in all planes, that is unpolarized. When you place the nickel prism, when light is made to pass through a nickel prism, you cut all the vibrations in different directions and confine, you see the vibrations only in one plane or in one direction, that is called the polarization of light. Plane polarized light, where it is passed through certain materials, this you know, the plane polarized, the plane or the direction, this direction will be rotated, or the plane in which vibrations are, they will be rotated through an angle theta. So, it is called rotation of plane polarized light. So, if the plane polarized light is made to pass through certain materials, so you can have sweet sugar solution. If light, plane polarized light is made to pass through saccharimeter, saccharimeter means sugar solution. So, if sugar solution is one thing which is tasty, and also it can rotate the plane polarized light. The plane polarized light is made to be incident on a molecule which is a polar molecule, then the plane of vibration has been made to go through an angle alpha. This angle through which, you know, the plane polarized light is made to undergo a rotation, right. Plane polarized light is here, when it is made to go through a saccharimeter or a polarimeter or some material, there are certain materials are capable of rotating the plane polarized light through an angle theta or through an angle alpha. This is called the rotation of plane polarized light. This rotation of plane polarized light is very important in what? In a very different area called food technology. You know, food, you know, making curd, whether the curd is properly made, or if you purchase coconut oil, is really coconut oil, all these things and tested by measuring the angle alpha. You get coconut oil or some other food stuff which is you know, having some refractive index density and so on, the viscosity. Now, when light is made to pass through these materials, the alpha is differing, that means your coconut oil or your food stuff, your curd that you are buying is contaminated. So, in food technology and very many other areas, it may look to be pure physics, it is not pure physics, it has got Polaroid, cameraide and cricket players using this kind of sunglasses, very many sunshade and automobiles, this polarization plays a very important role. And so, a plain polarized light, when it is passed through a saccharimeter, a sugar solution or through certain molecules which are having different dipole moments, then the plain polarized light will be rotated from through an angle theta or alpha, that leads to what is called rotation of plain polarized light. Now, through what angle is rotated? What is the concentration of solution? So, there is a law given by Biot. Biot's law defines the proportionality that exists between the rotation produced by an optically active medium. As I told you, usual thing is the students do saccharimeter, polarimeter experiment. You have a tube in which you sugar solution you are keeping and you find the angle alpha and the concentration, the length of the tube, length of the light path or the length of the tube through which light is passing and so on. So, let me now come to the law. The observed rotation alpha, the angle of rotation alpha depends upon the number of molecules encountered and is proportional to the path length L. The longer the path, alpha will be larger, concentration C, and therefore, the one defines specific rotation alpha as alpha is equal to 100 times small alpha by C the concentration and L is the length in decimeter of the tube through which light is passing through. You can have a sugar solution of concentration C and light is made to pass through the sugar solution contained in a tube of length L. Length of the tube expressed in decimeter, and this is a law given by Biot. Okay. Optical activity, this optical rotation, optical activity, all these things are observed as early as in 1811 by Arago, when he observed that rotation of a linear polarized light after passing through a quartz plate along the optic axis. Effect is due to helical alignment of the molecules in the crystal. Linear polarization light changes the direction of polarization after passing through such crystals. This is the optical activity. The linear or plane polar light, they changes the direction or getting rotated. Materials with optical activity are crystals like, as I told you, quartz, NaBrO3, Benzene, organic compounds like sugar solution, tartaric acid, turpentine, proteins. There are some other things, right, which make the plane of vibration to be rotated through some angle. The nickel prism is one which is observed by nickel. Calcite is colorless and absorbs very little of either ordinary or extraordinary light. Very pure calcite called island spar was once used to make a very good kind of polarizer called a nickel prism. A crystal of calcite is calcifery shaped and cut in two, as I will be showing in the next diagram. You cut a calcite crystal into two halves, and in between the two halves you put what you call a substance called Canada balsam, and then put these two together, and the light beam will be split up into two rays. One light beam will be split up into two light beams. One is called the O ray. O refers to ordinary ray and other refers to extraordinary ray. Both of them will be polarized and they will be travelling in different directions. As you will be seeing in the next diagram, they are travelling in different directions because the variation in the refractive index of the material calcite and also the Canada balsam kept in between the two prisms. You got this is a nickel prism which consists of a calcite crystal, you got a calcite crystal, okay. Then you got a material called a cement or Canada balsam. The ordinary is you see that the light is coming here. When it enters the calcite, it gets split up into two rays. One ray will be going like this and it is coming like this. It is a unpolarized is made to be plane polarized, it travels in this direction, it is called extraordinary ray. Whereas the ordinary ray which obeys the laws of refraction, the Snell's law, sin A by sin R is equal to mu, it is called ordinary ray, that travels in this in a different direction, right. For every ray which is made to pass through a nickel prism, for every ray you will be getting 2 refracted rays. It is called double refraction, and the 2 rays will be travelling in different directions, and they are called the ordinary ray and the extraordinary. And the material which makes this kind of phenomenon is called a calcite crystal, and in between this you got a cement. The calcite crystal is cut into 2 halves, okay. Then they are cemented using a material called Canada balsam. Let me not go into details, and the refractive index of the calcite and the Canada balsam are different. That leads to this kind of total internal reflection and all these things. And the important point is both the rays, ordinary and extraordinary, both of them will be plane polarized. This is one method of producing plane polarized light by nickel prism. Using nickel prism, ordinary light can be converted into plane polarized light. For one light beam will be having 2 beams, both will be plane polarized. Okay. Suitable direction of incident unpolarized light, the ordinary rays are total internally reflected at the boundary with the glue. Glue is Canada balsam, while the extraordinary ray passes through directly. This gives a separation of light into 2 components with the different polarizations travelling in different directions. Nickel prism has the advantage that the light coming out is completely plane polarized and it is not tinted, and so both the light beams will be polarized. This is a polarized light, this is polarized light, one is the extraordinary and the other called ordinary. Okay. To measure the optical rotation of solutions, make use of a polarimeter. A polarimeter is a glass tube containing a analyzer and a polarizer. Analyzer is a nickel prism, polarizer also is a nickel prism. You have a light source, you got a polarizer and you got a analyzer. Okay, this is analyzer, this is a sample tube, you call the whole polarimeter setup. What do you have in a polarimeter? You got a light source gives rise to light is coming here, it is unpolarized light. The unpolarized light wherein the vibrations are in all directions, the vibrations are cut off by polarizer, it is a polarizer. It will show one sidedness, it will cut all the vibrations in different directions and will lead to only the light vibrating in only one plane or one direction. It is a 2-dimensional picture in one direction, but all the vibrations will be in this plane, right. It is a plane of vibration. Okay. That is then sample tube, analyzer, viewer and all these things. This polarimeter can be used to determine the nature of the liquid medium, saccharimeter, the optical activity, the angle of rotation alpha can be measured. The measurement alpha will throw more light, and we will discuss about it in detail in the next lecture to come. Now, we will pass on to summary session. Unpolarized light will be converted into plane polarized light when passed through a polarizer. An analyzer is used to study the nature of polarized light. Polarization can be produced by reflection. Certain materials are capable of rotating the plane polarized light and is called optical activity. A polarimeter can be used to study the optical activity. Nickel prism is capable of producing double refraction. We have move on to questions. Question number 1, what is meant by polarization? 2, is polarization capable of finding the nature of light, either transverse or longitudinal? 3, what are the methods by which light can be polarized? The last question is, what is optical activity? With this we come to the end of this lecture session on polarization. The few of the applications of polarization we will see in the lectures to come. Thank you.